Welcome to the Home and Energy Chats webinar series and our episode dedicated to building a non-toxic home. My name is Heather Chandler and I am the owner and publisher of Green and Healthy Maine Homes. We have a great presentation tonight with some rock star presenters. This is a very important topic for all of us, but it's also a topic that, as you will hear, is really critical for people who experience chemical sensitivities. So I am looking forward to learning more, and I'm honored to be able to share this with all of you tonight. So I would like to start by sharing a special thank you to our sponsors, including our spring season sponsor, Senecal Construction Services, now offering net zero ready design build packages in Pownell, conveniently located minutes from Portland, Freeport, and Brunswick. And a word from our presenting sponsor, Royal River Heat Pumps.
Hi, I'm Scott Libby, owner of Royal River Heat Pumps. A long time ago, the Royal River, like most rivers, was an important part of life, powering mills and allowing a community to grow and flourish. Nowadays, we see what a river can help to create. We believe that ordinary people can come together to make a big difference too. This year, Royal River Heat Pumps will invest our advertising dollars into a new campaign we've launched called Ripple to River. Each month, we'll choose a different nonprofit organization whose focus is kids battling childhood illnesses. We'll tell you about their particular mission and let you know how you can help support them. We're also launching an online resource at rippletoriver.com, providing information and a link for donations. Little things can turn into big change. I'm Scott Libby from Royal River Heat Pumps in Freeport, and I hope you'll join us in making change happen for kids and families that are facing challenges that nobody ever wants to face. Visit rippletoriver.com to learn more and donate, and thank you.
Thank you to both of our Home and Energy Chat sponsors. And a quick overview of the presentation this evening. We will begin the webinar with a presentation from each of our panelists and then open it up to discussion with plenty of time for questions following the presentations. We did receive some questions through the registration process, and if you have others now or as you hear from our presenters, please feel free to submit them using the Q&A feature at the bottom of your screen, and we will do our best to get to all of them. And a reminder that this webinar will be recorded and uploaded to our website, greenmainehomes.com. If you are not familiar with us, Green and Healthy Maine Homes is a multimedia brand dedicated to inspiring healthy, sustainable, energy smart, and future-ready Maine homes through a quarterly print magazine, an online business directory, monthly email newsletters, and an active social media presence. Please visit greenmainehomes.com to learn more. And now it is my honor to introduce our panelists for the evening. Chris Briley is a founding partner and principal architect at BRIBURN. He is a certified passive house consultant, advisor, and blogger at greenbuildingadvisor.com and co-host of the Green Architects Lounge podcast. He is an enthusiastic participant and part-time moderator for the building science discussion groups, a founding member of the USGBC Maine chapter, and a founding board member of Passive Maine. He is also a co-author of the Pretty Good House book, along with our next panelist, Emily Mottram. Welcome, Chris.
Thank you.
Emily Mottram is the founder and principal of Mottram Architecture. Emily also teaches building science and sustainable design at local community college and has served as a consultant for projects in secondary school trade programs. She hosts the weekly podcast E3, Energy and Efficiency with Emily, and also co-hosts the BS and Beer show. And last but not least, we have Chris Genest, who is a general manager of Genest in Sanford and president of its Comfort Block division. He has 25 years of concrete block and paver manufacturing experience, as well as retail store management, product design and development, masonry, home building, and land development. So welcome, Chris, Emily, and Chris. As you may have noticed, you do not see Emily on your screen. She is going to be joining us in video format for the presentation as she's traveling today and is hoping to be able to get to her hotel in time to join us for Q&A. So let's fingers crossed that she is able to join us. And at this point, I will turn it over to Chris Briley, who is going to kick off the presentations.
Thank you, Heather. And it's great to be here with everybody. And Yes, so as Heather said, she did a great job introducing me, so I barely need to introduce myself, but I am Chris Briley. I'm a principal at BRIBURN, Maine licensed architect, certified passive house consultant. I'm a co-author of The Pretty Good House and co-host of the Green Architects Lounge, and I am not a chemist, and I am putting that in big capital letters because there are going to be moments when you're going to think, well, this guy really knows his stuff about chemistry, and that's not true. I know it by accident or because I had to learn it because my clients are sensitive to chemicals, and so we have to start scrubbing them from our buildings and practices, and it becomes something that I'm I'm becoming more and more passionate about. In fact, I will tell a quick story right before we get started about that sort of sets the tone about how I'm frankly super grumpy about the building industry and the industry in general here in the United States. So a quick anecdote story, my partner Jen and I, we were renovating our kitchen. We were going to be without a cooktop for quite a while. While we were fine with sandwiches and smoothies and salads and stuff, going without coffee, that's some pretty tough living right there. So Jen, on a whim or on a sort of impulse buy at Target, got a rather inexpensive hot pot for cooking water and boiling water. And when we got it home, we're like, oh, okay, that's a great idea. Maybe we'll use that even afterwards if it's nice. And we opened it up and just like it smelled like plastic, like you could just smell the bisphenols just like wafting over. So I'm like, oh, this is terrible. And then we noticed that picture of that glass pot, it's not glass, it's plastic. It's gonna boil water in a plastic thing. And then I'm reading the instructions and it says, the smell will go away after the first few times you use it, boil it a few times and then start using it. I'm like, there is no way in hell we're using this. And then I started thinking, who would buy this? Who would sell this? Who would allow this to be on the market? And here in the United States, we don't have a proactive government body regulating toxic chemicals. We do we have the FDA for food and things that we eat and consume, but we don't for products, especially building products. We do have the Consumer Protections Corporation, well, whoever they are, but they're not proactive. There's so we have the Aaron Brockovich method of enforcement, which is we need people to sue a company to the point where they will stop putting this toxic stuff in our homes. So anyway, I'm on my first slide. I have a problem with brevity. I'm going to have to go faster, so we'll go next. So my anger makes it so that I bring that anger into my job, and people recognize it. They say, hey, can you use that anger for good and help me get the toxins out of my house, especially for the clients who are chemically sensitive. Oh, look, a shameless plug for a book that I'm writing with Emily Mottram. But this shameless plug, I put it in here because we cover the subject of toxins in your house, and I'm actually going to be kind of mirroring that approach, which is also mirroring another approach by sixclasses.org. And I'll do next here. Oh, I'm not in control of the slides, so I'll be saying next a lot. And I also don't have my notes, I'm realizing that I have on my slides. So again, the sciencey parts I'm gonna be mispronouncing stuff. It's gonna be fun. Anyway, so what I'm gonna be covering is what to watch out for the products that you're bringing into your house, because industry does not care about your health. And if there's one thing to take away from this presentation, or at least my section of the presentation, is when we're done, go to sixclasses.org, and there's even more information. It's sort of an elaboration of what I'm talking about, because you'll be like, huh, sounds like Chris took a lot of that information from these guys. Yeah, I do a lot of learning from these guys, and it's a great method for scrubbing this stuff from your buildings, because basically they break bad chemicals down into 6 classes and then says, just avoid them as much as you can, wherever you can. And that's the best thing you can do, because it's really hard to get in there and parse out, animal, vegetable, mineral, what are all these products made of that you bring into your buildings? Anyway, I have to move faster. Next. So here are the 6 classes. They are PFAS, which are in the news now. So a lot of people know what PFAS are, but we'll cover that. It's basically highly fluorinated chemicals, antimicrobials, flame retardants, bisphenols and phthalates, solvents, and certain metals. But here's the thing, there should be some trigger words, things that make you, like when you hear something is stain resistant, that should be a trigger that makes you go, oh, that probably has one of these 6 chemicals in it. Because if you need to say it's stain resistant, then it probably wasn't originally stain resistant, which means now it has a chemical that makes it stain resistant. So when you hear stain resistant, non-stick, waterproof or weatherproof, fire resistant, antimicrobial, rot resistant, pest resistant, fast curing or quick dry, chances are very likely it has one of these 6 chemicals, classes of chemicals in it or on it to make it, to give it that feature. So next. Number 1 on the list, the first class is PFAS, or highly fluorinated chemicals. Next. And here we go. Ready? My non-sciencey is polyfluoroalkyl substances. It's not that. These substances are usually coatings on materials that we bring into our buildings. The most famous of all these is PFOA. If you've shopped for a non-stick pan, you've probably seen on the little sticker or on the pan, it says PFOA free. I've got bad news for you, Jack. Sometimes those chemicals that are PFOA free are very close cousins to PFOA, and they just haven't been through the system yet. They're probably going to get banned, but probably later. So non-stick pans, as we, let me get to it. So so that is like the most studied of all the fluorinated chemicals, because we heat it up and we consume it, and it has been known to cause all kinds of troubles, such as kidney and testicular cancer, elevated cholesterol, decreased fertility, thyroid problems, decreased immune response systems to vaccines in children. Next. So basically, we want to avoid those. Where are they found in your buildings? Carpet. They're found in carpet all the time. Even the green carpets, the carpets that have a high recycled content or even recyclability of carpets. So you have to really get in there, and especially if they're saying they're stain resistant, what is making them stain resistant? The actual fiber itself, or a coating on the fiber that's making it stain resistant. It's also hard, so the PFAS, they are by and large inert when they're on these products, and they're not really that much of a problem. But when they rub off and you consume them and they enter your system, that's when it becomes a problem. Or you heat up something with it, or burn it and inhale it and that sort of thing, that's when it gets bad. So it's usually worse for the applicators and the builders and people using this and manufacturing or disposing of it. That's more of a problem. Things like sealers for concrete, or grouts themselves have PFAS in them. All kinds of glue binders for woods and sealers for woods, as well as caulks and adhesives, and even coatings on metal and things. We kind of give things a pass if they're on the outside of the building in terms of the inside or in your indoor environment. It's not going to be hurting you. But you think about just all these things that we bring into our buildings and that we come in contact with constantly and use. And the baby crawling on the carpet and all that jazz. If it's covered with highly fluorinated chemicals, that could be pervasive and with them for a while. Next. So what do we do? Well, avoid carpet is one of the things I say. If people who know me, they know I'm anti-carpet, and if it's not the PFAS that is the reason, I always like to throw out that little factoid that the average carpet weighs 3 times what it did upon its removal than it does going in. And you can ask yourself, it weighs more. How's that possible? All the dirt and the dead skin and all that jazz. It's just not a healthy product. And I have seen new offices that are 4 years old get a new tenant, and what's the first thing they do? They rip out the carpet and they put in their new carpet. And did they call that carpet brand to recycle it and take it back? No, it didn't. It went in the landfill. So I'm anti-carpet. Does that mean I've never specified carpet? No, in fact we have. We've been very diligent about the kind that we bring in. But anyway, I gotta move faster. The other thing is to use solid wood whenever you can instead of engineered wood. This is a very tricky thing, especially in today's building climate. And that just by using a solid piece of wood, you're not introducing glue binders and high emitting coatings and things. And we'll talk about VOCs, volatile organic compounds, and having products that are low in VOCs in a little bit. But if you use low VOC sealers for wood and concrete, that helps. That goes a long way. We often go to Vermont Natural Coatings or AMF Coatings. They have a slew of coatings that are 0 VOC and don't have the PFAS in them. Same with adhesives and caulks. And also, if you limit the number of sealants and adhesives on a job, that also helps. Next. The second class, I'm gonna have to go faster, I'm sorry. So antimicrobials. Something being antimicrobial sounds great, but if you are chemically sensitive, like some of the clients that I've been working with, the chemicals that are being used to make something inhibit the growth of live things is also a toxin and causes problems. Topping the list is triclosan, which goes under the marketed word or the marketing title microban. I have and because there are so many other chemicals out there that I don't even know about and don't even know how to list them. But antimicrobials such as triclosan, one that's most studied, have been linked to hormone disruption, negative developmental reproduction effects, and increased allergen sensitivity and asthma. Next. And these can be found in and even advertised as having microban in them proudly to inhibit mold and mildew, tile and grout, textiles and fabrics, and even air filters themselves. So if you've got a client suffering from MCS or multiple chemical sensitivity, and you think you're doing a good thing by putting an antimicrobial air filter to keep the microbes down and mold and mildew out, you're actually introducing a new chemical, a new incitant into their system. Next. So what do we do? If you're using antimicrobials, you are treating the symptom and not the cause. And basically, what you need to do is figure out what's creating this mold and mildew problem and remove that, and not just treat it by using, and instead of having curtains that are treated with an antimicrobial coating, because your other curtains got mildew on them, that means your window is terrible or that you have some other humidity issue. By the way, there's a great episode of the Home Energy series, a few episodes prior to this, all about mold, and so I don't need to get into that, and I have to be careful, but we don't have time to go see that one because it's good. Is the treatment worse than the illness? This is something to ask yourself about microban and triclosan. Do you really need it? Keep organics out of high relative humidity spaces such as basements. They're often, especially here in Maine, if the relative humidity is like 50% or higher, you really don't want organics down there. And if you've got concrete in contact with wood, remember, concrete is often a porous material that is absorbing water from somewhere, even the air, if the relative humidity is high enough. And it's often colder, so that brings relative humidity down. When temperature decreases, relative humidity goes up. And so if you have wood, that is food for mold and mildew, and ta-da, you've got a problem. So keep those guys isolated. And then as an architect, we have to make sure we build assemblies that can dry. And this is an episode all into itself, and Heather, maybe we do that later. That's a good one. Okay, next, I gotta go faster. Flame retardants. Next. And when we're talking about flame retardants, we're talking about organohalogens and organophosphates. They are pervasive bioaccumulators. In fact, almost every American that's been tested to see if they have flame retardants in their system has tested positive, meaning we, right now, all of us, have these chemicals rattling around our bodies, most likely. And a lot of that is because I, as a child, probably slept on a mattress that was sprayed down with flame retardants because everyone was petrified that people would be smoking in bed and lighting themselves on fire. So they have mattresses with flame retardants. Our parents' generation, that was pretty much all they slept on, sat on for furniture. In fact, if you buy furniture right now today, you should find out, has it been treated with flame retardants? And then ask yourself, do you need flame retardants on your furniture? Are you going to be smoking and falling asleep and then lighting yourself on fire? Anyway. But these same flame retardants, let me go next slide. These same flame retardants in the building industry can be found in a lot of places, again, on your carpet, and then in building insulation, and then, of course, treated on all kinds of wood and other products that could end up in commercial settings or in places of assembly, cabinetry and millwork and things where the manufacturer doesn't know, does this need to have a Class A fire rating? Does it need to be having a reduced flame spread? And if so, I better treat this thing. And then you've got flame retardant chemicals on it, and that's a problem. This middle photo, which has XPS insulation, which is an insulation that we are trying really hard not to use in our office, is extruded polystyrene as opposed to expanded polystyrene. Expanded polystyrene, if you're not familiar, is the styrofoam cup, the beaded styrofoam. And this is extruded polystyrene, and it has a slightly higher R value, higher compressive strength, usually, and is used in the building industry all the time. It's usually blue like this or pink. This photo is from one of our own projects. Like this photo is like maybe a few days old. Our drawing said EPS foam, our spec said EPS foam, and yet when the pictures come in from the job site, what shows up? XPS, because that is what builders are used to using, and they think, hey, I'm doing them a favor. It's higher insulated value. We've got acres of this stuff already. Same thing, potato. No, it isn't, because XPS almost always comes with flame retardants already built into it, and oftentimes pesticides, and has terrible global warming potential. That's another topic, but so we're trying to use EPS instead of XPS when we have to use insulation buried in the ground, and it has to be something like this. So this is a BRIBURN project using XPS. I'm trying, but I'm failing. And this is a good house, and they're going to love it, and they'll be fine because this is buried. But here we are. It's like, it's hard to do. This is hard to do. So next. So what do we do? Stop using XPS insulation, use untreated EPS instead. It's an easy swap. If you have to use a petroleum-based insulation. And then I put this in, really stop using XPS. I'm trying to hammer it into our office and myself and make sure we follow up with builders and let them know why we put EPS. It's not because that's the one we chose, there are reasons. Again, avoid carpet altogether. And if you must do it, don't purchase any that has been treated with flame retardants. If any wood products, for some reason, say that they are flame retardant, ask yourself, why? And does it have to be, and is there a more appropriate material that can go in here? If your project includes furniture or textiles, make sure they're not treated with flame retardants. Okay, next. 4, oh my, bisphenols and phthalates. I have to go fast. This one is by far the most difficult to avoid, but and basically the trigger things are, if you ask yourself, is it a clear plastic? It probably has bisphenols. Is it a UV stable, durable plastic? It probably has phthalates. And both of these chemicals, like so BPA. BPA is that chemical, if you remember, like in Maine, we tried to ban BPA in baby bottles, and our former governor, not this governor, but the other one before, was famously, had that comment about, he vetoed it because it was bad for business, because, what's the worst that could happen? You grow little beards, what a piece of work. Anyway, sorry, not to bring politics into it, but that's sort of what we're facing. All right, so But BPA is the most studied because it is the one that was in the clear bottles that we're drinking all the time. And it simulates estrogen, has been linked to asthma, neurodevelopmental problems such as hyperactivity, anxiety, depression, and aggression, especially in children. In adults, it's also associated with type 2 diabetes, heart disease, obesity, prostate cancer, decreased fertility. You get the idea. And then phthalates have been shown to show cognitive deficiencies, behavior problems, asthma, allergies. I'm just reading the slide. That's not good presentation skills. Anyway, moving on. But like I said, these things are everywhere. And by and large, they're completely inert. Once they're hardened, cured, and in our environment, it is when we are making them, they're toxic, when we're disposing of them, when they're toxic, when we're cutting them, burning them, manipulating them, that's when they're toxic. Over time, they age really slowly. They do leach out dioxins and other toxins, depending on their chemistry or whatever. But mostly they're inert. So we try to avoid them, but there's some PVC pipe. Oh my gosh, we have tons of that. You see PVC everywhere, from railings to decking boards, which is the one on the bottom, to the vinyl flooring, vinyl siding, and your polycarbonates, your clear plastics for greenhouses, etc. So we try to avoid them, but do what we can. Moving faster. All right. So try to avoid them. For clear plastics, PET is better. For plumbing, HDPE, which is the black plastic tubing, is better. High density polyethylene. All right, next. Solvents, next. And basically we're talking about hydrocarbon and halogenated organic solvents. All right. And with solvents, what the thing to look out for is VOC, volatile organic compounds. And basically it's for anything that was a liquid and needs to dry and become solid. And we're talking about paints and spray foams, etc. So solvents, they're most dangerous when they're inhaled, but they can be absorbed through the skin and consumed. That's when they are the most dangerous and cause all kinds of problems. Next. You will find them in paints, as I said, all kinds of adhesives, caulks, and sealants. And the thing to do is to look for VOCs. If it's a zero VOC product, if it's low in VOCs, those are volatile organic compounds. Those are like usually that smell of the paint carrying, ooh, that usually smells really good, but that's bad for you. And I've got a little slide in here about spray foam, because spray foam is a solvent, and we in our office are trying not to use spray foam, but we end up using it where we can. And we'll probably talk more about this when questions come in about spray foam. But spray foams come in many degrees of super evil for the environment and to not so evil, but they are all very evil when they're being applied. You have to wear a hazmat suit, and you can't be in the building if you're without one. And if it's installed correctly and properly, then it is inert when it's done. But then that's a bit of a trick. So anyway, moving on. So what do? We use zero or zero VOC paints. Almost every paint company now has them. Use materials that don't even need coatings is a great strategy. The LEED standards set great standards for VOCs for all these different applications, adhesives, paints, and everything. And there, you can just go online and look for those standards. Your codes have those standards as well, but LEED is usually a couple of steps ahead of them. And avoid spray foams if you can. Next. And then the last class is certain metals. This one's we're talking for the building industry, we're only talking about 4. It's arsenic, cadmium, lead, and mercury. And really the question to ask yourself is, am I renovating something? Because that's really when you're going to run into this problem. They've been led to, well, we really don't need this little part because basically they're bad news, especially for the young. And we all know about lead paint as being, we've all probably signed a waiver at some point when we took ownership of a house or an apartment or something like that. That we knew that it was a dangerous thing, but do we really know how dangerous? Next. So when you're renovating, you can find it in lead paint, especially around old buildings. You find mercury in CFL or compact fluorescent light bulbs and regular fluorescent light bulbs. You find arsenic in pressure treated woods and other treated materials, but usually any pressure treated wood that's like before 2011, there's a good chance that it has CCA, which has the arsenic in it, and so you want to be careful handling that. And of course, if you're really into old stuff, there's good old-fashioned lead flashing, awesome stuff, but wear gloves and handle it well. And then trickier is the old solder and the old plumbing that all had lead in it, and you know, a lot of us still have our houses with this in it. Some well, not around here, but actually even have lead pipes, but hopefully not in Portland. Okay, so those are our 6 classes. Next slide. And oh yeah, so what do we do? So if you're renovating, try to identify the hazardous materials. The EPA has guidelines for these hazardous metals and how to deal with them. Hire a professional whenever you can, and then make job sites non-smoking zones, because cadmium is actually a pervasive heavy metal that hangs around even after the smell is gone. So yes, next. So then I'm going to real quickly talk about one of the projects that set me off on this is Habitat for Canaries. And this is a cute little cartoon basically talking about a pretty serious subject that my clients are basically 3 people, one of whom has, well, 2 of whom have MCS. One has MCS rather seriously, and that's multiple chemical syndrome, where, you know, for the mom, for the mother of the trio, it's a real irritant, really annoying. But for the daughter, it's a serious life-threatening health risk. And for people just like her, it's really hard to A, get diagnosed, and B, get treated, and then C, once you are treated and at your baseline, really difficult to make and create an environment for yourself. Anyway, they are creating a place called Habitat for Canaries. We can go next. And they're creating it in Hiram, Maine. And it's called Canaries because, like the canary in the coal mine, the canary is just like you, only sensitive, way more sensitive. And so they're creating a place where people like them can go and heal themselves, get to that baseline, educate themselves, and then you know, go on with their, and hopefully move on with their lives with this knowledge and this baseline and education. Anyway, we're doing a little retreat for them, which is a compound and little nests, if you will, as well as a house for each of them. Next. And then this is a quick glimpse of the house as it's being designed right now. And the only thing really to point out here is it's basically 2 houses. The little shed on the right is actually where the mechanical equipment is going, because they also have EMF sensitivities. And there's so many things in mechanical equipment we can't control that are really hard to parse out. And so it is all in this building over here. Next. And I will move quickly. I won't linger on the building sections. We can geek out. But basically, I thought when I took on this project some years ago, because it's been a process, that I'd be doing an all natural house with all wood and all this stuff. No. She can't handle the polyoxyphenols of wood, you know, that nice pine smell, the hydrocarbons and stuff. She can't handle wood. So soft woods we can't do, cellulose we can't do, the formaldehyde binders and insulation, the fiberglass and mineral wool she can't do. So the only wood she can really tolerate is like a hard maple. And so we have to find products that work with her. Because we're lucky, she's at her baseline. We can actually mail products to her to test. We're wrapped in foil. She tests, she brings them into her environment, or actually her mom does first, because she's just like her, only less sensitive. And she can tell right away, no, this is not going to work. And then she gets, no, this one works. And then we can test it with Lindsay, and if she can handle it, then we can build from it. So the house ends up being built from ICFs, from EPS, and there's one brand that's working. So it's concrete, it's metal deck, metal studs, and it's one particular spray foam, the isonine spray foam, that is an open cell. And so there's a lot of detailing that we had to do. And so I'm showing after this slide. All right, next. So tools that we as designers can use, and maybe you too, if you're designing your own house, there's, we did a living building challenge project, which has this tenacious red list, this list of chemicals that you cannot have in your project because they are considered toxic either to the occupant, the installer, or the person who has to deal with it afterwards. And they have a database that they have made as they are trying to vet all these materials. And it is called Red to Green, and the website is called Materially Better. You yourself can register, become you can look through their material database. You can put in sheetrock and then see if they've tested any of them and what score they've given it, and links to that and everything. It's wonderful. They're great people. It's called Red to Green. It's a great resource. Next. And then this is just this is one of our own spreadsheets for the project, where we've actually gone through our specs and put down every item that we can think of, and then basically did our research on it, and we're going to send it to Lindsay, have her test it, and then are we currently researching it? Was it declined, or was it approved, etc. It's just like, basically what I'm saying is here, can you track down and identify every material that's going in your building? That in and of itself is a hard task. Anyway, next. And I think I'm done. So next up is Emily, and I'm sorry I took so much time. So thank you.
Thank you, Chris. That was really some helpful and a little bit scary information, but I do appreciate it. So let us move on to Emily's presentation.
Hi, everyone. I'm Emily Mottram. I'm sorry that I couldn't be here to join you this week on the show. Unfortunately, due to a schedule conflict, I couldn't join you live, but I wanted to make sure that I was able to come on and talk to you a little bit about this project because this is such a hot topic and so important to us and how we practice our business. I'm a small firm architect here in Maine. You can reach out to me via email, my website, follow me on Instagram. That's where I am most active. I'm also on LinkedIn and Facebook. You can find me on the E3 podcast, Energy and Efficiency with Emily, as monthly podcasts that I release, and also live on Thursday nights on the first Thursday of every month for BS and Beer. We also have all of our previous shows up on our YouTube channel, The BS and Beer Show, so you can find me there. This is a project that I worked on. It's a 5-lot subdivision in Cumberland. All the houses are high-performance houses built to the Pretty Good House standard. They're all solar oriented, and they all focus on healthy indoor environments for as much as possible. Another shameless plug, Chris is also on the show tonight, have just completed a book that'll be out in June, where we talk a lot more about chemical toxins and how to handle and monitor what's in your house in the book. So I just wanted to throw this up there. That'll be out in June. So if you're really interested in this topic, this book is going to go into more of that than we could probably get into tonight. I want to talk about this project. This particular project is for a homeowner that was diagnosed with multiple chemical sensitivities and a neurological disorder surrounding that. And so it was really important for her to build a house that she could live in and get back to life as normal as she could. So they moved from their 4th floor apartment in Boston to Maine. As they were searching for sites to live in, build a house on, they actually counted the number of cars that drove by. So she knew she couldn't be anywhere near a major traffic area, but also as a mom with 2 kids in school, she wanted to be in a good school district. So they happened to find this piece of property. There's about 1 car that drives by every half an hour. So they felt pretty comfortable with that. And they also sleep with the windows open as much as possible in the shoulder seasons and in the summer, so that they have access to natural outdoor environments that will be helpful to her. Part of doing that meant that we needed to reduce as much petroleum products and VOCs in this house as we possibly can. So we used a natural shingle on the house. It's untreated. It'll weather to a beautiful patina over time. And we used a soy-based concrete release form for the concrete release. So the homeowner actually bought it and gave it to the contractor so that they would use that over a petroleum-based product that's typical for concrete release. This is the compact house. It's a small house. As you saw in the picture, we did actually add the bedroom and the 1-car garage to this as well, but it's a very compact space. So we had to get creative with our space, but it was really important that the two kids had their own bedrooms, so they have really small bedrooms, but they have their own space. But also that they needed to stay within a budget, so they couldn't build a very large house. They were coming from an apartment, so they were used to small spaces. We actually built a double stud wall with cellulose insulation so that we could use an insulation that did not have petroleum in it. So it was really important for her. And we lucked out with our team. It was very, very important that we found a team that understood what she was looking for. So the owner actually talked to all the subcontractors to just remind them that we were trying to reduce this. And that meant that we should give everything that we do just one extra moment of thought so that if we could eliminate petroleum from standard practice, we wanted to try to do that. And so the best thing that we did actually was find a builder whose standard of practice was to use board sheathing and board flooring. So instead of the typical plywood that you find in most houses, we were able to eliminate petroleum and plywood throughout this entire house. When you walk into this house, it smells like a pine forest with the board sheathing and the board siding. And then everything that we got, for the most part, was unfinished and finished on site with either zero VOC paints or Vermont natural coatings, so that we could make sure that we could control what was on our materials and what was encapsulating those materials that we did bring into the house. So part of that was also to have a local craftsman build out kitchen cabinets for them. Typically, kitchen cabinets are made of some kind of plywood or, other material that has a lot of glue in it. So by working with a local craftsman and doing a lot more joinery work, they were able to cut down on the amount of glue that was in the project. And they were also able to control the finish that was on their cabinetry. So she was able to pick a zero VOC paint for the cabinetry. It was really important to the client to try to eliminate as much petroleum and VOC as we could in this project. She was also adversely affected by mold. So when we had to do a full basement under the house just because of the geometry of the site, we made sure that it was clear to her how to handle a dehumidifier, how to condition the spaces, and how to be aware of excess moisture in the house through monitoring. So we wanted to try to prevent any future mold growth wherever we could so that she did not have issues in the future. And as I mentioned before, she spent a lot of time before purchasing this piece of property understanding how much traffic would go by this site. Again, I mentioned that we controlled all of the finishes. So again, you see here with the zero VOC paints, we have sheetrock returns on all of our windows, which gave us actual storage on our windows by having our windows set to the exterior. We ordered all of our windows with wood interior unfinished, and they finished those with Vermont natural coatings. We did the same with our window sills and any trim that we had throughout the house. So here you can see the flooring, the doors, the trim, and on some of our walls, we had boards on the wall instead of sheetrock so that we could reduce the number and amount of sheetrock we have in some places as well. So everything was unfinished and delivered to the site and finished with a coating that we knew would have no VOCs. This is the kitchen and the main space that we had at the house. Because they had a small budget, we had to be really creative with space. So we built this built-in bench to the back side of the island. So they still have an island in what is considered a relatively small kitchen, but have dining room space for the three of them or the four of them when her mother is over. And we have plants on our south-facing area so that they can have lots of natural plants inside the house. You can see the finished floors here were wood, the wood on the stairs. There's no carpet in this house. And they were very particular about the furniture that they brought in was either old furniture that had off-gassed any materials that it had in it over a long period of time, or it was finished with a natural material, including, what's in your couch when you buy it and stain resistant on all of those things that can come with a lot of chemicals in it. So she was very, very careful about the different parts and pieces that she brought into the house after the fact. Here's our built-in bench that adds seating to our space, but actually works in a very compact way. What we did was to eliminate toxins wherever was economically possible. So that's a pretty good house tenant, is that you try to do the best you can until it no longer makes economic sense. Getting wiring that doesn't have plastic is possible, I think, but not very practical. So we tried not to do things that weren't practical so that we could meet her budget, and where it wasn't practical, to eliminate plastic or petroleum-based products or things that had VOCs in them, we did ventilate. So we put an ERV into this house so that we could dilute anything that we did have, and also try to maintain good indoor air quality in the wintertime when she can't open the windows to sleep outside. And we made sure, doing a final client walkthrough, that she understood how to dehumidify, how to monitor interior VOCs and spikes in those. We eliminated any kind of fossil fuel based systems within the house. We do have heat pumps. There's one on each floor. The heat pumps are one heat pump head to one compressor on the exterior, so that we could cut down on the amount of line sets that run through this structure so that they go directly outside. So it's the most efficient way for her to run her heat pumps. And also it is cutting down on the amount of line that we might have to run into this space. So the final thing that I want to mention here is, same with interior and exterior, we controlled all of the materials that we put into the house. We controlled the finishes that went on those materials. And then we built her this screen porch so that she could sleep outside during the really nice times of the year, so that she can have a place where she can go and she can retreat to that's outside of the house, because we do spend a considerable amount of time inside our homes. So it was critically important to know what materials we had, what those finishes were. It was vital that the homeowner knew how to operate, maintain, and monitor her home once we left. And it was really important that we had the right team. So we had an incredible builder. We worked very well together as the three-legged stool, as Mike Maines would say, between the owner, the architect, and the builder. Everybody was on board. All the subcontractors were on board, so that they understood there was a reason why we were doing things a little bit differently on this home, and that both her health and the economics were critically important. So that is what we did at this property, and I hope that you enjoy it. I'm sorry that I can't be here. I'll try to join for Q&A, but if I'm not, please reach out to me afterwards. I'm happy to answer any questions that you might have.
It's great to see another case study and put some of the concepts that Chris covered in the first presentation to use in another real life house. So at this point, let's turn it over to Chris Genest.
Thanks, Heather. And thank you for the introduction earlier. I think that covers it quite a bit, but in a nutshell, I'm part of a family business, been around since 1927. We manufacture concrete products. I co-general manage, owner and operate Genest in Sanford with my brother, Matt. Started Comfort Block a number of years ago in our hopes of creating a product that would catch up to speed with what was going on energy-wise, performance-wise, so that people could build or have the option to build a concrete structure if that is a material that was preferable over wood. Wood structures are nice, but sometimes you need a different tool for the job. So we're hoping to give some answers to people if they need another material. Next. So this is my low and non-toxic masonry home presentation. This is a model home that we built in Arundel, and I will go through this. This is an all masonry home, masonry on the exterior and interior, as well as a porcelain roof tile. So it's a fairly resilient, durable exterior, kind of prone to not rot. So it's pretty nice. Next. So the goals while we were building is basically use the most natural products possible when we were building. I really dislike smells, odors that are too strong. That was my basis. It was really not overly scientific. If it really stunk, or if it had a lot of glue in it, or it looked cheap, I just didn't want to use it. My thoughts are that the products need to be really simple with as few ingredients as possible. They have to be resilient. And I think a finished home should exceed minimum codes for safety, health, and energy efficiency. So we really kept all this in mind when developing the product, but also building with our product. Next, please. We have one of the systems we have, which we make which we build most of the houses with, is called the CB16 system. It's a 16-inch thick wall. It has 3 layers of insulation. There are electrical channels built into the block so that it's easy to put and run electrical in after the wall has been constructed. Saves on people overlapping trades. Also eliminates furring and sheetrock and siding. So we really try to stick with, like what Chris said, try to keep organics away from concrete. So you really have to go all in order for it to really work. Otherwise, you really have to watch what you do and what you put against concrete, because it can get cold and create situations you don't want. Next, please. So the CB16 system, designed to be used, energy efficient hold, home building, maximum durability. It's manufactured to a precise height. It's ground, so we actually put it together with an adhesive, which the reason for the adhesive was that we don't have many masons anymore. And so the people don't really know how to use mortar like they used to. So we're having to develop products to be better or easier to put together. It's just our adapting to the environment we're in. Again, built-in electrical channels, no drywall, estimated performance of an R30, 16-inch thick wall. Next, please. So I'm going to go over the basic construction because probably most people that are watching, and most people in general, at least in the Northeast and in Maine, are not familiar with concrete block construction as when you use it for a home. So I want to go over everything so you can really understand at least what's behind everything that you see when you see the finished product. Next, please. This is a basic view of the wall. It's really not complicated. It stacks up, you glue it together. Rebar can be placed where it's needed. In this case, roughly every 4 feet vertically. You can see it. We grout that to make it stronger. It goes all the way up to the top where it ties into the roof. Next, please. This particular site it had a lot of clay and it had a high water table. So really, to put a basement in would have been a lot of work, and typically basements are problematic. If you don't keep them dry, they can produce a lot of mold and mildew and moisture that can resonate up into the house. It's just really not worth it. And I would hate to build a house like that and sell it to somebody and have problems. So we just put a frost wall in, filled it, and continued to build from there. Next, please. The walls, all masonry, it's monolithic. It's a monolithic shell with the insulation in the block. So it's already, once it's up, it's already insulated. The lintels are a multi-piece lintel over the windows and doors for the most part, with a piece of EPS between them to help break that transfer of cold or heat through into the house. A lot of the lintels or headers over the garage doors and major entranceways that are more substantial are cast in place with rebar. And then the anchor bolts are put on top, which the roof is fastened to. Next, please. You can see here that the roof is really tied into the gable ends. So it's incredibly resilient. The anchor bolts go through 2 plates on the top, and in the hurricane straps hold the trusses down. We had to use PT on the top of this wall simply because it's code and it's on concrete, so no one really likes it. I'm going to try to work on that. In my opinion, I don't think it's needed. I think you can use maybe another barrier to just go between the blocks and the wood. That would cut down on cost, and also just the pressure treated lumber, which is, I think, is kind of nasty. If you don't need it, then I don't like to use it. Next, please. This house has radiant heat. So because it's a slab, we use EPS. We use 4 inches of EPS, and we crossed We use 2 layers of 2-inch, and we cross them so that there's less joints. Then we use the EPS all around the edge as well. So that made for a really comfortable, nice floor. It keeps the whole house all the way to the edge of the house warm and dry. This helps in a concrete house where you might have cold areas build up if you put something against the wall. So you kind of have to work with concrete just a little bit differently, but if you know the system, it works really well. It keeps it a lot cleaner, a radiant floor, less dust floating around, less, I don't know what you call it, just circulation in general, because it's a nice even heat. Next, please. Inside, we used all concrete masonry as well. We have another system. This is CB6 and CB4 system. It's all the same type of construction. There is no sheetrock in the house until you get to the ceiling. So it really is limited on exposure to products, to mold and damage on the walls in general. So there's no drywall in any of the verticals. There's electrical channels in the block, so you can put the electrical right in the block and that you don't have to fur it out. Next, please. In the attic or in the roof, in this particular shot, this is my house I built a little while ago, and I went with mineral wool. I really liked it. It doesn't burn. Bugs and rodents don't like it. It's quiet. It seems to fit better in between the framing. It resists mold. The Arundel house has blown-in insulation, but I really like this compartmentalizing of the insulation, say over spray foam, more for practical reasons. If anything ever happened, you can kind of pull it out and you can really dissect what's going on if you happen to have a roof that fails or leaks or whatever. It just seemed like a really good way to go. So that's why we choose it, and that's why we recommend it. Next, please. This is a picture of the block wall before it's coated. You can see the electrical boxes. The blocks are designed to receive a standard electrical box. Then the box is flush with the face, and then you can easily plaster over it. And when you're done, it looks, you can see the picture to the right, it looks like a regular drywall. And then you can paint it. We typically use low VOC or no VOC type of paint. Again, if it has a real strong smell, I don't like it. So I try to get everything I can. When the house is done, it just smells very little, very clean. Next, please. The exterior, it's block, and then we put a 2-part system over it. It's basically a latex sand type of application. So it's a stucco, and it's incredibly waterproof after it's done. All the exterior that we do, we recommend using granite sills. Don't need a granite header, that's just for a different look. But then we use UPVC triple pane European windows. I'm assuming that a lot of the European windows are at a higher standard than the ones we use here in the US, which is PVC. Not knowing too much about it, Chris, you probably know a little bit more, but nothing on the exterior of this house, with apart from the wood trim on the top, is exposed to a situation where it's going to rot. So an incredibly durable exterior shell. Next, please. We're working on a block and beam floor system, and this is being engineered now so that we can produce a modular floor system and it goes well with load-bearing structures, as you might imagine. So very typical, like a block and plank concrete hotel. They'll use blocks and planks all the way up. So durable, fire, safe from fire, compartmentalizes fires in a multiple dwelling application. So we're excited about this. Next, please. And you can see this is a block and plank, block and beam floor system setup. Couple different photos. Most of these are from Europe. It's very common over there to have this type of stuff. So we're really not inventing it. We're just kind of bringing it here. Next, please. This is a house we built for a young lady who had mold toxicity syndrome or mold toxicity. Incredibly sensitive to smells, paints, mold. If she get around any kind of mildew or mold, it would really set her off. And she had aches all over her body. And she was really desperate. She found us and just thought it was a good opportunity to build a small house so that there was no exposure, at least on the exterior of the house, or minimum exposure to possibility of mold and mildew. So it's a masonry exterior wall. She put metal stud interior walls with drywall. She has all low or no VOC products. There's a fresh air unit exchanging the air all the time so that it's a healthier atmosphere and filtering it. She has no carpets. She has a concrete floor that is with a low VOC stain and sealed. Next, please. This is some of the interior shots. So the kitchen there down on the left is really close to being finished at this particular time. I took the photo. That's all block walls, plastered and then painted. And the kitchen is mounted. I mean, a little different to mount some of the cabinets. You need to use some concrete anchors, but by and large the same. And then there's a picture of the steel studs there with one of the fresh air units that she has sitting up there. Next, please. These are some of the interior shots of the rest of the house. So it really ends up looking like a normal house, like everyone's used to. All clean surfaces. But this is not far from really the way we like to build anyway. It just happened to be that's the way we built, and it worked out for her. Next, please. So when we get to the model home that we built, in order to show people what a concrete home could look like, and that it's not a big scary block house. So we built this, and we'll take you through the interior. Next, please. It's another angle. This is the inside and the kitchen. All the cabinets are, we bought these, we got these from Performance Building. So they're in Portland, Performance Building Supply. They have low VOC cabinets. These are all like natural wood all the way through, even in the back. Anytime we could use natural wood without glue, we did. Next, please. We use tile throughout the whole house. It works well with radiant heat, easy to clean surfaces. I think, as Chris indicated earlier, talking about something that's stain resistant, in my opinion, just to have a good hard surface that's easy to clean is the best thing to have, and you don't need to worry about the stains as much. Next. Interior of the bedroom. We do have mini split heat pumps in this house as well for the shoulder seasons. It's a lot more economical. That way you have AC as well. So we have one pump with two heads, and it easily takes care of the whole house. The house is fairly efficient, so that worked out well. Next, please. This is a picture of the hallway. We do have a fresh air unit in this house. It's a small one, but it runs slowly, continuously. So the house does smell fresh all the time. It's nice. Next. The bathrooms, anywhere the showers were and where there's a lot of steam, we made sure there was a lot of tile on the walls. There's only drywall on the ceiling. I like clean surface. It's easy to wipe down. You can get it wet and you're not going to be worried about it. These are all masonry walls as well. The tile works really well on that, goes right on without a problem. Next, please. That's the other master bedroom, bathroom, I should say. Again, tile all the way to the ceiling, tile behind the toilet, all wipeable surfaces. Next. This is the garage. Again, keep everything clean. This is as insulated as the house, apart from the garage doors, which are gonna leak a little bit, but by and large, it's a really comfortable garage to be in. Next. This is a utility room. It's a little trash, but we took the picture anyway. We just stuff a bunch of stuff in there. You can see up on the right, there's a small fresh air unit. There's a gas unit that we did use for the radiant heat. It's set up, at least it's set up nicely for radiant heat. Someday there will be a really good system, I would think, that's going to be run by solar or a heat pump. But at least the house is set up for that moving forward. We had to do a lot of, we had to put a big water system. There was some arsenic in the water. So we have quite a filtration system, but it works really well, very healthy. It doesn't stink. Next. And that's just a picture of the dry bar because, you know, that was a cool thing. Next, please. That's it for what I have to show. Trying to look in a couple notes that Chris was talking about. Yeah, basically that, you know, the blocks themselves, it's a good product if you're looking at situations where you might need, you're in a higher moisture area and you're concerned about mold and mildew. If you're in an area where you need some fire protection, you know, products that are treated in order for them not to burn just might not be the product you need. You know, you just might need a different tool. And what we're working on is to have a tool you can use that is a little more sustainable than it has been in the past. It gives you a greater value and you feel better about using it, but it also accomplishes what you need to, which you might need a really durable structure in certain situations, or you might want to have a fire wall application. So it's an option. So if no one's familiar with masonry, hopefully that exposes you to what can be done with masonry. And we continue to work on new products, making it more environmentally friendly and really more healthy. That's my passion, and we continue to work on it every day. Thank you.
Thank you, Chris. That was great. We normally end at 7:15. I just want to do a quick check. Do you guys have an extra 15 minutes if we extend to 7:30 so we have time for Q&A? Okay, great. The first thing I want to say is that I hope you know that you are all doing an incredible service to people who are living with and suffering from chemical sensitivities. And I had an employee years ago who did have severe sensitivities as a result of a chemical exposure. And I know from firsthand experience just how stressful that was for her to find housing that worked for her. And even when she'd go through all the hoops to make sure the housing worked, sometimes the environmental exposures outside the house would have an impact on her. And it's just, it's a really stressful thing for people who are dealing with that. So I think what you're doing is great. And unfortunately, we're seeing more and more people who do have these sensitivities. And so hopefully we'll see more of these products and this awareness grow into the future. So with that, I'm going to turn over to a few questions. We did have several questions come in with registration, and also some additional questions have come in through the chat tonight. So I'm going to start with a question from June Donenfeld, which is, how much off-gassing is there from the adhesives in OSB and other sorts of engineered woods? And is it all contained by the sheetrock, or does some of that still seep out? Who would like to take that?
I'll jump in, and Chris, feel free to jump in at any time. Or did Emily make it? Did she? Or we don't know. she'll chime in, I'm sure. Anyway, yeah, OSB and other engineered woods, they do have a substantial amount of outgassing, formaldehydes and glue binders that that do outgas quite a bit. And if you remember, the FEMA trailers were famous from the which disaster was it? The New Orleans, I think, Hurricane Katrina, I think, where lots of people were put in little Katrina's, thank you, little brand new trailers made with tons of OSB, and they all came down with asthma, all kinds of respiratory problems. And OSB, but the real answer is it depends. I mean, there are different products with different binders and different outgassing. So like Advantech is nowhere near as bad as regular off-the-shelf OSB, in my opinion. And it really is, you have to dig into the manufacturer literature. Almost every product has an MSDS report that you can get that really is not that helpful, because it really is usually like, how hazardous is it under fire conditions and other things that really you just want to know, what is the outgassing of it. And the part two of your question is, when it's behind sheetrock, does that contain it? No, the answer is absolutely not, especially if you have multiple chemical sensitivities. In fact, the tighter houses that we are building now sort of magnify the effect of these things that we bring into our indoor environment, stay with you longer.
Yeah, I think, Chris, to add on to that too, I think there's of course was getting expensive, right? And so there's a push for OSB because you got to save money where you can. I think when we build things, we use plywood whenever we can. I know it's not as dimensionally, it's a little more floppy than maybe some of the products that are more engineered and more precise, but they seem to be proven over time, and they seem to be rugged once they're in place. I think they mold a little bit less, or they last a little longer, and they don't smell. So I guess we try to use the older school type of products whenever we can, when we need to use wood.
Yeah.
All right, this one is for you, Chris, Genest. I guess I'm going to have to use your last names.
Okay.
Are the recommended coatings for the block that you use low VOC?
It's a latex base. The cement based product on the first coat is low VOC because it's essentially concrete. It has some polymers and stuff in it that make it a little more sticky. We have MSDS sheets on those. The stucco itself is a latex paint, so it would be similar to any latex paint you see or in the paint store. It's basically just has sand in it to make it more durable and give that texture. I do not know how much off-gassing it has, if it has any though, so I don't know that offhand. But the product we use is called Parex, Parex. There's other products like Stow, STO, and Drive It. And I'm sure they have more information on the websites, on their own websites.
All right, this question is not so much about building material as what we put in our homes. She is considering a wool mattress. The thought is that they are naturally antimicrobial. Can you speak to wool products? Are 100% wool carpets okay?
I mean, I think a wool, well, like a wool rug, like something you can take out and beat and clean and shampoo or whatever. I would think that would be better than a carpet. Or if you're talking about wool carpet as opposed to like a chemical one, I would think it would be better. Personally, I know that my clients for the Habitat for Canaries project project, like that she can't handle lanolin. Like it's like that, the same thing that helps make it antimicrobial, that oil is something that she reacts to. So it's, and maybe I should comment on that. Like everyone is different. Like everyone with chemical sensitivities has different levels and different things. So to one person, like Emily's client, probably like pine was fine, wood was fine. To mine, it's not. But and so I don't know if I'm answering that 100% right. I don't know that much about wool as per se, especially as a mattress, I think.
Chris, I would think that you probably want to just check if it has like a fire retardant or other things that they treat it with. That's probably more of a concern. I mean, if that's what you're thinking about, but I would think that the wool would be relatively nice and natural, but if they add things to it, that's what you're gonna look for, in my opinion. That's what I would look for.
All right. There was a question on mineral wool insulation, which I know, Chris, Genest, you touched on this in your presentation. Anything else to say about mineral wool insulation? Chris Briley?
Yeah, mineral wool, like it's interesting. Like I try not to use that on the indoor environment as much, because it, like it is, so mineral wool is basically made of basalt and steel slag usually, which is basically like rock and like the leftover bits of steel foundry or whatever, and it's heated up and spun like cotton candy and then bound together, pressed, usually with some kind of glue binder that historically has had some amounts of formaldehyde in it. And so I tend not to invite that into the interior environment. I usually use cellulose is our default insulation in our office. So we usually use that on the exterior. But that's not to say that there are no studies that say it's awful, but if it's got any formaldehyde in it, I'd rather not have it on the inside. But it is, as Chris mentioned, dimensionally stable and hydrophobic, and rot resistant. So it's pretty good for replacement for some of those EPS boards and stuff that I was talking, EPS and XPS boards for exterior applications.
Another question on hempcrete. Anyone have any experience, information, knowledge of hempcrete?
Yeah. Go ahead. Yeah.
I can. I guess I've done some research on it, and I wish it were really easy to do, because then you just throw hemp in it and it's like, yeah, let's make blocks out of hemp, right? And but then the ASTM comes in and goes, whoa, time out. What are you making? So we can't really just make blocks out of hemp without a lot of testing and all that kind of stuff. I do have a bale of hemp stock in our lab, and I will at some point try to run blocks with hemp stock in it, a certain percentage to lighten it up, to take up the volume. It reduces the natural aggregates that we need, so that lasts longer. From what I understand, hempcrete, you can make it with limestone, and then over time it cures. The problem with mass producing it in a block is that you can't put lime only in it, because the next day it's not cured. You have to have high temperature and high pressure kiln systems, which costs millions of dollars to do that. So it's really problematic in a high production facility. On site, if you're doing it by hand, it's not bad. I mean, it's a labor of love. I think it's a good product. I think there's a place for it in high production in concrete blocks eventually, but it's going to take a little bit of research and testing and to get it approved and all that. Because when you put something organic in a block, it's no longer considered a concrete block, and the engineering is off. You can't get engineering, you can't get anybody to sign off on it. But I think it has potential. So we're going to try that eventually.
Yeah, our office is working on a project right now. We're partnering with a couple who they are actually going to do their own hempcrete house. So we've been doing our own research, and like you said, Chris, it's not, here in Maine, it's really hard to put a stamp on it and engineer with it. And so basically it's a post and beam, it's going to be a post and beam house with, a hempcrete infill, around it and in it. And for those of you not familiar, hemp, if you just take hemp hurd, which is the fibrous hemp, strong hemp fibers, mix it with lime, pack it down really, tight, it has this reaction with the hemp hurd and actually kind of cures hard. And because of the lime, the pH is really high, so it's actually becomes sort of like this mold inhibitor just by its pH level, and it cures hard. And so you have this hard, hempcrete. It feels more like concrete, fibrous, like concrete that you can finish with a plaster or some other material like that. But like Chris said, it's a labor of love. It's not like I can go hire a contractor to go do it. These people want to do it. They're going to do it themselves. And I think there's an army of people that want to, learn and jump in there and roll up their sleeves and do it too. And we're excited to help them with it. So, and it's great for the environment from a embodied carbon standpoint. So that's one reason for championing that.
Definitely start hearing a lot more about it.
Yeah.
This question was partially answered in the chat, but I'm going to put it out there in case there's anything else you want to add. And it is, when discussing underslab insulation, I was told by my builder that EPS absorbs a lot of water and XPS does not. Is this true or false?
It's like true or false or true, whichever you want to. I hope I'm not lagging. I'm shaking my head. But so yeah, I think EPS does absorb more. Helen, I saw it, like Helen put up a link or something. Someone was answering it. Was that Helen? But
the question was David Gulick, and Helen did put a link up in the chat.
All right, well, I try her link, but I'm guessing that link is going to say something like EPS probably absorbs a little bit more. But if your builder's doing your job right, you're not depending on EPS to block water. I mean, you use membrane to use waterproofing and that sort of thing. And I don't think the water is going to have a significant effect on its ability to thermally protect your concrete. So it's like, yeah, it might, so my response to that builder would be like, so if it absorbs a little bit more water, then, because it's not a lot, but if it absorbs a little bit more water, as long as it insulates as well, and you're waterproofing your concrete the way you're supposed to be through vapor barriers and whatnot, then yeah, who cares? Use it.
Sort of feeds into this next question a little bit. How many people trade off health corners for less cleaning and replacing, which impacts their daily life? How do you or would you evaluate for product durability and maintenance for clients?
Chris, you're gonna take that one?
See, the last part of the question, Heather, ask that again, I guess.
The last part, how do you or would you evaluate for product durability and maintenance for clients?
How do I or would I evaluate for product durability? Well, I mean, the products that we have, I guess, are proven to be durable and long lasting. So there's low maintenance on it. There are, I guess there's product lifespan studies, Chris, correct?
Yeah.
That you can go to. Blocks are one of them. Wood house construction. I mean, everything has that. And I don't know where you go get that. I forget, Chris.
Well, it's like you can do. There are different software like that architects can use to do life cycle analysis. But I think it really is going to come down to like a client's preference. I don't know how many times I've had clients come in and say, like, I want a completely maintenance-free house. I want maintenance-free, durable, maintenance-free, and I want it to be completely sustainable and all organic and whatnot. And so you kind of have to say, well, all right, like you can do an all concrete house, and but it might be that that's not their that might not be what they want. Like wood siding's a great, example. Like you could do cedar shingle siding, and as long as you have the rain screen air venting behind it, that shingle is going to last, a really long time. It could be like 30, 40, 50 years, even if you're doing if you did a good install on that shingle. But if you did a lousy job, or if you started painting it and committed that original sin of painting it, like only on one side and not doing the air, rain screen behind it, then you're going to be painting that thing forever, or you're going to be replacing it faster. We might make the decision, oh, let's use, a stone, veneer, and that's going to last a really, really long time, but that's money. So it's like, there's all these things to balance out, and you need the client's input, the owner's input on what is comfortable for them in terms of their durability, and what does durability even mean to them.
I don't think it's a trade-off for the health either. I think it's just a matter of familiarizing yourself with the right products that are out there, and they typically are older, traditional building products that are very simple. And it's just educating yourself how to use them in a way that it's now going to be more energy efficient and up to modern day building practices. So it's a little bit of a research, but I'm convinced you can build a house that's really healthy but pretty durable.
On that note, I think we do need to wrap. We are coming up on 7:30, so I do have a few final remarks. First of all, I want to thank you, Chris and Emily, for sharing all of this great information and for your time this evening. I'd like to thank everyone who joined us tonight for this episode, and also our sponsors, Royal River Heat Pumps and Senecal Construction Services. Special shout out to Rain, who you can see her photo here, but she's beautifully handling everything behind the scenes, as she always does. If you do have any questions that we didn't get to today, and I know there are quite a few, we will include contact information for our panelists in a follow-up email, along with a link to the recording. It will also be available on our website in the next couple of days at greenmainhomes.com, and as well as all of the recordings of past episodes. And this is also where you can find information about upcoming episodes and sign up for our newsletter to keep in touch. And lastly, you will see a brief survey pop up when we close the webinar. We'd love to hear your feedback on today's session to help us craft future programming that meets your needs. And so with that, I will say thank you again, and look forward to researching more of this. There's a lot of really good information here, and I think, like I said, you're going to do a lot of good for a lot of people for a long time. So thanks again, and we'll talk to you soon.
Thanks, everybody.
Bye.
Bye.